I welcome you to NEET World. So in this session, we'll be continuing our 100 days challenge for NEET, JEE and EAP set. Okay, so it is day 2 of this 100 day challenge. So where we will be focusing on most important topics of the all competitive exams for your JEE, NEET and EAP set. Okay, so these sessions are very useful for all your preparation. Okay, so whatever the exam you may be preparing, so these topics has to be must be learned by every aspirant. Okay, so in the last session we have discussed about this mole concept, right? So methods of calculation, mole concept, number of moles, how can we calculate, okay, and the numericals based on this. So we have discussed, and today we will be discussing little more about that. Okay, we will be continuing yesterday's discussion only. Okay, I hope I have given some questions to you in the yesterday's class. Okay, so let us look into that question first and let us continue further. See, the total number of protons in 10 grams of calcium carbonate. So how can we do this? See, given how many calcium carbonate like species are given, 10 grams is given now. So now we need to convert given weight into what? Into number of moles. Therefore we will get, first of all we need to find number of moles of calcium carbonate. So why do we need to find number of moles of calcium carbonate? So once after knowing number of moles of calcium carbonate, we know 1 mole calcium carbonate contains 1 into Avogadro number of calcium carbonate units. In each calcium carbonate, so in each unit of this calcium carbonate, formula is CaCO3 now. So calcium atomic number is 20, so 20 protons, and carbon atomic number is 6, so 6 protons. So oxygen atomic number is 8, so 8 into 3, so it will be 24. So totally how much it is? So 50 protons are there in this 1 unit of calcium carbonate. So now finding the number of moles after multiplying that with Avogadro number and also multiply with this 50. So gives us number of protons in this calcium carbonate. This is the concept which we need to use here. Okay, so now number of moles of calcium carbonate, how can we find? Given weight is 10 grams, so take given weight by its molar mass. What is the molar mass of calcium carbonate? It is 100 now. How do we do this molar mass calculations? So just use this formula. See, take its chemical formula. So calcium atomic number is 20, so mass number will be double of it. It means 20 protons 10 and plus 20 neutrons. So totally 20 plus 20 40, and carbon here, so atomic number 6, so mass number 12, and the next here 3 into 16, so totally it is how much? 48 plus 12 plus 40, it is 100, right? So this is what you got. So that's why I have taken gram molecular weight as 100 gram per mole. So this gram cancel, 10 100, so it will become 1 by 10 mole. 1 by 10 mole I can write as 0.1 mole. Okay, you can write like this. So in 1 mole we know Avogadro number of particles are there. In 0.1 mole, multiply 0.1 into Avogadro number. Okay, so into number of protons in one formula unit is 50. That's it. So Na means Avogadro number na 0.5 into 6.022 into 10 power 23 into 50. This is your answer. Now look here. So 0.1 into 50 means I can remove this 0 and this one. Okay, so 5 6 are 30, so I can say, so 30 into 10 power 23 will be our answer. So similar to this, do we have any option like that? We need to check. Okay, so there is an option like this, 3.0 into 10 power 24 also we can write. Yes, see, 3.0115 into 10 power 24. Yes, this is our option. Okay, hope it is clear how easily we are solving this kind of questions, like, okay. So I hope you are really understood this question. So if it is really true, just click on the like button, and also I suggest you to share with your friends so that it will be helpful for them also. Okay, and you can join our Telegram group also, where we will be updating you about the classes. Okay, so what are the sessions we are taking in the upcoming classes, I mean upcoming like time schedules I am saying. Okay, all these pre-planned things will be shared in the Telegram so that you can access them early, and we will also be sharing some important questions, materials, all the things. So that is the source we can have one-on-one meeting also. I mean, we can clear your doubts also in the Telegram. So you can join that using the link provided in the description box. Okay, so this is the thing I can tell you now. The next thing is here, calculate number of moles of carbon atoms in 90 grams of glucose. So tell me how many moles of carbon atoms are there. How can we do this? See, they have given the weight of glucose and they are asking about number of moles of carbon atom. Very easy question again, okay, but you need to use your brain properly. So glucose, what is the formula of glucose you need to know? C6H12O6. This is the formula, no? Okay. So in one formula unit, how many glucose atoms are there? 6. How many carbon atoms are there in the one formula unit of glucose? We have 6 carbon atoms, right? So if number of moles of glucose is 1, in that we will be having 6 moles of carbons. Hope it is clear. And if the number of moles of glucose is 1, and how many moles of hydrogens will be there? See, in one formula unit 12, na? So in 1 mole it will be 12 moles of hydrogen. Similarly, 6 moles of oxygens will be there. Like this you need to understand here from the given chemical formula. So now what is the weight they have given here? They given 90 grams. No? Find the number of moles of glucose. Number of moles of glucose is given weight by its molar mass. Okay, so this will be 1 by 2. So 1 by 2 is 0.5 mole we can say. Okay, so 0.5 into Na. This gives the number of moles of number of glucose units are there. So how many? 1 by 2 into Avogadro number. So in 1 mole we have 6 carbons. In half mole we will be having, in 1 mole we have 6 moles of carbons. In half mole we will be having 3 moles of carbon atom. That's it now. So I can say so 1 by 2 into Na means Avogadro number 10 power 23. This many number of glucose units are there. So in 1 unit we have 6 carbons. So number of carbons, number of carbon atoms equals to this one, like this. So it will be 3 times. So how much it is? 6, 18.066 into 10 power 23. So this will be our answer for number of carbon atoms. Okay, carbon atoms. Now I will be asking you in the comment box. So tell me how many number of hydrogen atoms, how many number of hydrogen atoms in the same quantity, and how many number of oxygen atoms. So I want answer for these 2 things in the comment box from your side. Hope it is clear what I am asking exactly, right? Next, this is done. So next, what about percentage composition? Okay, so I wanted to ask you about this, and you can take this as a homework question based on the discussion which we have did till now. Okay, so take this as a homework and tell me the answer. Now I will be explaining you percentage composition. So this is of 2 types. One is percentage composition by mass, another one is by mole. Okay, so what exactly by mass? See, let us take methane. I am taking. Now what is the percentage composition of carbon by mass in this methane? So we know what is the molecular weight of methane. For carbon it is 12, for hydrogen 4 into 1, so overall it is 16. So total molecular weight of this methane is 16. Now I am asking about percentage of carbon in this methane. Na? So what is the total weight of this methane? 16. Na? So take the total weight in the denominator, that is 16, and what is the weight of carbon in this 16? That is 12. So take it in the numerator and multiply with 100. So now what is the formula I have given you here? So percentage of any species if they ask, so you can take total weight in the denominator, total weight, okay, in the numerator, weight of component, it means here carbon is a component. So the weight of component here it is carbon, na, that is 12, okay, into 100. Okay, percentage of a component I am writing. So that is weight of component by total weight into 100. So this is how you can make your own formulas. Okay, so now from this, so tell me, so this is 4 3s are 4 4s are, so this is 25 times. Okay, 4 into 25, 100 will be getting. So what is the weight of carbon here? That is 75%. Percentage weight of carbon is 75. Hope it is clear. Now I am asking about percentage weight of hydrogen from here. So simply there are 2 ways. Now this molecule is made up of carbon and hydrogen. So overall weight percentage, let us say 100. Out of that carbon weight is 75, just remove that, you will be getting 25 percentage is the weight percentage of hydrogen, like this. Or simply use this traditional method only. What is that? Percentage of hydrogen equals to, how many hydrogen atoms are there? 4 are there. Each one mass unit is 1 and overall mass is 16 into 100. So this is 4 4 is 16, right? So 16 into this 100 here we have. So 100 by 4 means 25. Percentage of hydrogen is how much? 25%. Like this also you can do. Hope it is clear what exactly percentage composition by mass. Here similar to this we will be having mole percentage, and there is a JEE question based on this mole percentage in the previous year. Okay, so let us understand that also. Okay, so here percentage of carbon by mole, here I am saying, that is by mass, this is by mole. Okay, equals to what we can say, number of moles of carbon by total number of moles into 100. So it is nothing but percentage composition of a particular component by mole equals to number of moles of that component by total number of moles into 100. That's it. This is the formula you can use here. So now here let us say same unit will take. So in methane what is the percentage of nitrogen, percentage of carbon by mole I am asking. So it means in 1 mole of methane, let us say, how many moles of carbon will be there? 1 mole of methane contains 1 mole of carbon, 1 mole of carbon and 4 moles of hydrogen, you should say, because in one formula unit we have 1 carbon. Na? So similarly 1 mole of methane will contain 1 mole of carbon and 1 mole of methane will be containing 4 moles of hydrogen. Hope it is clear. Now percentage of carbon by mole if they ask, so how many moles of carbon are there? 1 mole, and total number of moles are how many? So this is 1 plus 4, that is 5 into 100, that's it, you got the answer. This will be 220. Okay, 20 will be the percentage of carbon by mole. So you got 2 different answer. See, percentage by weight, if I ask for carbon, that will be 75%, but here if I ask by mole, that will be 20%. Complete answers are different. Okay, so you need to read the question properly, what exactly they are asking, and you need to answer accordingly. Hope it is clear. Now if they ask for hydrogen, yes, I want answer for this percentage of hydrogen by mole in the comment box. I want from your side. So tell me what is the answer for this in the comment box. Okay, so just try to answer based on your understanding only. Okay, so let's move further. Yeah, this I have given as homework. Now tell me percentage of nitrogen in urea is about. Okay, what is the formula? See, they haven't mentioned about whether it is mole percentage or whether it is weight percentage. In this case you just consider it by weight. Okay, take the unit formula unit of urea. So what is the formula unit? This is the formula and structure of urea, right? Now what is the general what is the formula I can make out of it? So C NH2N2H4O, this is the formula you can write from this, right? So now what is its molecular weight? What is the molecular weight of urea? Here you can say, see, C we have now, so 12 plus 14 for each hydrogen, 2 are there, so 28 plus 4 hydrogens 4, so oxygen 116. So if you sum up this, you will get 60. What is the molecular weight of urea? 60. So out of this, what is the, I am asking in the question, percentage of nitrogen. So percentage of nitrogen by weight, if we consider weight of nitrogen by total weight into 100, right? So what is the weight of nitrogen? Here we have weight of nitrogen is 28. So in the numerator you can take 28. So total weight is 60, take it here and into 100, right? So this is how you need to write. So then next 0 0 remove. Okay, then next this will becomes how much? This will be how many times? 4 times you will get, 4 times 24, it means again you will be having 4 point, you can put 40. So 6 are 4.6, again 36 means again 4 is there, again 6, something like this. You will be having 4.6667 like that. So I can say 46.667 like this we can write. So this is the percentage of nitrogen we got. Okay, now look, the approximate answer here we have is this one. First option will be our answer for this particular question. Hope it is clear how easily we are solving this kind of questions, right? So if you really like this, just click on the like button first, all the viewers in the live. The next, now we have one more important formula, that is important concept, that is empirical formula and molecular formula. So what exactly it is? So see, we have the molecular formulas. For chemical formulas we can say, what is the chemical formula of glucose? You will be saying it as C6H12O6. Okay, so now this is the molecular formula of glucose I can write. Okay, now this is a molecular formula of glucose. Okay, so molecular formula indicates exact composition of each element in that molecule, right? But whereas empirical formula is the simplest whole number ratio of the elements, constituent elements in that particular molecule. For example, the empirical formula of glucose, if I want to write, EF means empirical formula, you can say this story is about glucose I am saying. Example is what? Glucose I am taking. So empirical formula means what? The simplest whole number ratio of the elements. So what is the simplest whole number ratio I can take? See, from these C I can write. So C6H12 means I can say 6 1 ja means C1, and H12 is there na, 6 2 ja I mean H2 I can write, O1 I can write. So this is the simplest whole number ratio of these numbers, I mean these elements, right? So that will be the empirical formula of this glucose. Hope it is clear. Now I can also make, so what is the whole number that we have taken here as a common? So that is how much? 2. So the n value is 2 in this first case. Similarly, now I am taking glucose is over. Next let us say this is example 1. Next example 2, I am taking acetic acid. Formula is CH3COOH, right? So now how many carbons are there here? 2 carbons now. So we can make C2H4O2. Okay, this is the molecular formula of glucose, I mean acetic acid. Now what is its empirical formula? Again look here, that is also in 1:2:1 ratio. So empirical formula will be CH2O. Okay, so what is the n value here we have taken out? That is whole number is how much? 2. Like this, if you understand everything, you will get the empirical formula and molecular formula. So you can expect something like it, you can conclude something here. So empirical formula may be same for different molecules also, but molecular formula generally it will be unique for different molecules. See, glucose and acetic acid both are having different molecular formula, but whereas its empirical formulas are same here. Okay, even for formaldehyde if we write, formaldehyde formula is what is that? COHH. So its empirical formula and molecular formula will be same. So CH2O. Okay, so n value is 1 here. Okay, so now we can conclude that molecular formula will be equals to whole number, that whole number into empirical formula. Okay, this is what we will get here. Molecular formula can be equals to n into empirical formula. Okay, hope it is clear. Vidya Roy, good evening ma. So I hope you are following the class. Yeah, I hope you got what exactly I am explaining here. Yeah, so let us look into few questions. See, I have a question from NEET 2024 which is very easy here. Just follow it. What the question is saying here, a compound X contains 32% of A and 20% of B and remaining percentage is C. Okay, so X is a compound which is made up of A, B, C. Okay, compound X is made up of A, B, C, and this contains A is 32% and B is 20%, remaining is C. It means a compound X is made up of these things now. So what is the total composition? Let us say 100. Out of this 100, 32 is A 20 is B, then remaining will be C only now. So what is that remaining? So 32 plus 20, it will be 52, 100 minus 52, that is 48% will be for C. Hope it is clear how we are able to solve this kind of thing, right? Yes, Vidya, just follow the class. If you have any queries, feel free to ask in the comment box. I am looking into the chat box also, okay? So, but please try to listen the class at most patience and with most interest, okay? Now, this is a weights we have. So now, how can we do this? See, then the empirical formula of the given compounds they are asking. See, they also provided the molecular weights of the atomic masses of A, B, C is provided, atomic masses is provided. Then from this, find number of moles of A, so that we will get how many moles of A is there in this X compound, and number of moles of B, okay, and number of moles of C. If you find this, what you will be getting? Number of moles, how will be finding number of moles? Given weight by its molar mass or atomic weight. So what is the given weight given for A? That is 32, right? 32 by what is its atomic weight given? 64. It means number of moles of A is 1 by 2. Similarly, number of moles of B is how much? So it is given is 20 and molecular weight is 40. So 20 by 40. Again, this is also 1 by 2. Okay. Similarly, NC you can calculate. NC is how much? NC means, so given weight is 48 and its atomic weight is 32. So what will be getting here? So 16 2 ja, 16 3 ja. So you got NC as 3 by 2. So finally what we got? A 1 by 2, B 1 by 2, C 3 by 2. This is the formula unit we got. But there is no option like this. So just simplify, try to simplify that. So LC, like see, denominators are same here. So I can write the formula as A1, B2, B1, C3 by cancelling out the 2, 2, 2, right? So what we got? A, B, C3. A, B, C3 is a third option given in the question. So option 3 is perfect answer for this particular question, right? So Vidya, I hope it is clear. So how we got the answer for this one, right? So now, then next we will be going through this stoichiometric calculations. Okay, so stoichiometric calculation here is, so what is the use of this? So stoichion means what? Okay, stoichion means elements, metry means measure. So during the chemical reactions, how these elements are combining, okay, and how the products are forming, and how much amount of these elements, I mean reactants, are involving into form the product. So this elemental measure we will be doing, and the calculations or the quantitative analysis we will be doing in this particular concept. Okay, hope it is clear. For example, we know carbon combines with oxygen and forms carbon dioxide. This is a simple reaction, right? So now, how much amount of carbon combines with this oxygen, then how much amount of this CO2 is formed. So this kind of calculations we will be doing in the stoichiometry concept. Okay, so here we will be taking methane as a general example. So methane plus O2 combines to form CO2. So this is a combustion reaction, H2, right? This is a species formed here. So 1 mole of methane, okay, combining with oxygen, forming 1 mole of carbon dioxide. Just try to balance number of carbons, here 1, here also 1. Then next, how many hydrogens are there here? 2 are there, so 2. Okay, now balance oxygen atoms here. So here we have 2 and 2. So it means 4 total. So you can take like this. Okay, so what is the ratio here we have? What is the ratio here? 1 mole of methane combining with 2 moles of O2, forming 1 mole of CO2 and 2 moles of water. Okay, so now like this we have got the mole ratio, 2 minutes, mole ratio based on the balanced chemical reaction, right? So based on the balanced chemical reaction, first of all write the chemical equation, balance it, therefore we will get the mole ratio like this. Okay, now here 1 mole of methane required, how many moles of carbon dioxide? 2 moles are required. Now for example, I am giving you 5 moles of methane, then how many moles of oxygen is required? Tell me how many moles of oxygen is required. For 1 mole, 2 moles is required. Then 5 moles, it requires 10 moles. This is how simply we can able to calculate how much quantity of oxygen is required. Otherwise, how much amount of CO2 is formed. See how much amount of product is formed. For each 1 mole of methane, forming 1 mole of CO2, right? So I have given you 5 moles. Then it will be also for 1 mole, it is forming 1 mole. For 5 moles, here also it will be 5 mole. Like this, simply by understanding what happening here, we can easily do this. Hope it is clear. Now instead of saying 1 mole, we know number of moles equals to given weight by its molar mass, right? So number of moles is given 1. What is the molar mass of methane? 16. So what is the weight? I can say weight will be also, so 1 into 16, that is also 16 grams. Instead of saying 1 mole, I can say 16 grams. 16 grams of methane reacting to form, instead of saying 1 mole of CO2, 44 grams of CO2. Hope it is clear. 16 grams forming 44 grams of CO2 during the reaction. Now I am giving you 5 moles. Instead of giving 5 moles, so I can say 5 into 16, that is 80 grams of methane combining with oxygen to form X grams of CO2. Can you find what is the weight of the CO2 formed? Yes, easily you can find. Okay, and I am expecting answer for this kind of questions in the comment box. Just tell me the answer for this question, and whatever the remaining things are there now, we will be discussing in the upcoming sessions. Now you will be having, if you are the JEE student, you will be having mathematics class, and if you are bio student, you will be having botany, zoology classes, as well as physics class will be there after this. Okay, you just follow all these classes. These will be definitely helpful for you. Okay, so Reddy's Princess, Medico. So thanks for joining. So you can follow the class regularly. These sessions are definitely helpful for you. Medico, Reddy's Princess, as well as Vidya Roy. Both of you can follow the class. Okay, so tomorrow's class we will be discussing about excess reagent, limiting reagent. We will give you a special, like, clear cut explanation on this, because very important concepts these are. Okay, so now, so if you are already aware of this excess reagent and limiting reagent, just answer this assertion reason question, and after this you can also solve one more question based on your understanding level. So this question also for you, those who are in the live. So just try these 2 questions. We will be doing in the next session. Thank you for watching. Yes, thank you, ma'am. So do not forget to subscribe the channel so that it will recommend you in the next sessions. Whenever we are taking live, that will be reflected in your mobiles as a notification. Don't forget to do that. Okay, thank you.